in case online people need help with this. I'm gonna record them, and this is where you're about to feel really silly. Like, oh, I don't know how to do that. What is this? Okay, I would put my axis right on that mass in the corner, the 150G. We can dispense with G's. And then so those other ones are also on the axis. That way I don't have some other coordinate for this. 75 G's and 100. Okay, somewhere inside the triangle is the center of mass. Make sure, so in centimeters, make sure we know exactly where everything is. So this would be the point minus 40, and this would be the point 03 and 00. Okay, drum roll please. What you do for the center of mass is do the weighted average. Oh, it's the weight. It's the center of gravity. So you weight the average. That's what weighted average is. They each have the different points have different weights, literally in this case, since it's physics, and you just find the weighted average. So, and now this is a coordinate, so that's a little mind-boggling at first. The location of the center of mass on the x-axis is okay. We take the x-coordinate, 0 times 150. Trust me, this is going to work. Plus negative 4 times 100. Here's the second one. Plus 0 times 75. Oh, but that's negative 400. How's that wrong? I didn't average it. I just got the weighted part. How do I, if I have different stuff, how do I make the average? Yeah, divide by the total. So this is a total of 325 grams, I think. So the location of the x center of mass, and by the time we test again, we should be able to do this really fast, is negative 400 gram dot centimeters divided by 325 grams. Okay. 325, right? Yeah. 1.23 centimeters. And in y, it's even easier, because there's these two that are 0. Oh no, I don't even need the 0. I need 3 times 75, again divided by 325, the total. Right? Grams dot centimeters, or centimeters dot grams, doesn't matter. Okay, 0.692. Okay, and it's positive. So that xy point is the center of mass of those three. It's just a weighted average in each direction. Treat the perpendicular directions independent of each other. Okay. Good, good, good. Oh my. A non-uniform density for number 70. Of length A and width B. Okay. Anybody still need this first one, 63? I'm gonna start 70 and then clip my video. Okay, I would absolutely draw their box. So it puts one corner at the origin, the width is B, the length is A on the x-axis, y-axis, and then it says the density rho in x comma y, so this is mass density, equals rho 0 times x. So this is like a knife blade or something. When x is 0, it's infinitely thin. It's a wedge, and then it goes thicker and thicker and thicker linear. So it's more like a cheese wedge than a knife blade, because the knife wouldn't get, it's not triangular, linear. Although maybe they could scale it and they don't give a scale. Pro tip, where is the center of mass on the y-axis? Right in the middle. Okay, it doesn't change. This is a function of y that has no y terms, so it doesn't change. So ycm equals b over 2. I should put b as this point up there. Okay, good. We did the easy part. Now what happens? Well, we're still going to do the weighted average, which is, right, before we did like a fancy, we did a sum of mass times m1 dot x1, and we summed them all, or we could do subscript I, yeah. We're going to sum over all the masses, okay, there were 3 in the last problem, and then divide it by the total. As I clip to the next video, in calculus class, what would that look like? Not a sum, yeah, but the integral of Riemann sum, no. What would our terms be? And we don't have. This is actually a reasonably solvable question.